quadratic forms, the final topic in maths actually. So in quadratic forms, we are going to discuss how to reduce a quadratic form to canonical form. That is key concept. Before going to discuss our actual topic, first of all we need to discuss what is quadratic form. So quadratic form means simply what we can say, a quadratic form is second degree homogeneous equation in n variables. A second degree homogeneous equation in n variables is called quadratic form. Second degree means degree should be 2. Homogeneous means all the terms degree should be equal. So example for this is, for example if you have a quadratic form like this, x square plus 2xy plus 3y square. This is quadratic form in 2 variables. Quadratic form means degree should be 2, degree of x square is 2, degree of y square is 2. You all know degree of one term with 2 algebraic functions, you need to add exponents. Exponent of x is 1, exponent of y is 1, 1 plus 1, 2. So degree of all terms are equal, homogeneous, and the degree should be 2. That type of equations we can call quadratic forms. This is in 2 variables. If you want, you can have 3 variables quadratic form also. X square plus 2y square plus 3z square plus 4xy plus 6yz plus 8zx. This is quadratic form in 3 variables. If you want, you can check all the terms degree is 2, 2, 2, 2. xy powers if you add 2, yz powers if you add 2, zx powers if you add 2. So these type of equations we will call them as quadratic forms. This is general definition for quadratic form. In the form of matrix, an expression of the form x power t ax is called quadratic form. We represent this one generally with q. An expression in the form x power t ax is called quadratic form in matrix form. So now the main intention here is to apply any application on matrix. First you need to write the matrix. Without matrix, how can you apply any operation? You can't. That's why what I am saying, in q equal to x power t ax, A is called matrix of quadratic form. Matrix of quadratic form, A. How to write this matrix of quadratic form from quadratic form? These are 2 quadratic forms which I written. How to write matrix from this quadratic form? Quadratic form means one equation. From this equation, one should write matrix A. That plays key role to do any application on quadratic form. That is very most important one. That I am giving one small easiest technique to write matrix of quadratic form. To write matrix of quadratic form for any quadratic form, first thing you need to remember is write square element coefficients in the diagonal. Square element coefficients, x square, y square, z square elements in the principal diagonal. You all know what is principal diagonal. Next, write remaining elements by dividing coefficients half. xy by 2, yz by 2, zx by 2. By dividing coefficients by 2, you can write the remaining elements. This is one way. The another way and best way to write a matrix of quadratic form for the given quadratic form is, first find out how many variables you are having in the given quadratic form. For example, I will write a matrix of quadratic form for first example, x square plus 2xy plus 3y square. First, find out how many variables you are having. How many variables you are having? 2 variables, x, y. So, with that 2 variables, roughly prepare a matrix like this, x, y. Multiply x into x, x square, x into y, x, y into x, yx or xy, your wish, yx, y into y square. So after doing like this, except square elements, remaining all elements make half. That means excluding these x square and y square, divide remaining coefficients by 2. Now what it represents? It represents, write here square element coefficients. Write in this position x square coefficient. What is x square coefficient? You are not finding any number there. That means you will have 1. Now here write xy coefficient half. Xy coefficient is 2. 2 by 2 is 1. Next, here yx or xy are same, xy coefficient only, make it half, 2 by 2, 1. In this place, write y square coefficient. What is y square coefficient? 3. Like this, one can easily write matrix of quadratic form. So that's what I said, simply keep square element coefficients in principal diagonal and make half remaining elements coefficient and write in respective positions. Respective positions means xy is here, here you need to write xy half. Yx is here, here you need to write xy coefficient half. Like this, one can easily write matrix of quadratic form not only for 2 variables, for 3 variables also. To write for 3 variables, you need to write one more element here, z, z. Again multiply like this. We will discuss anyway, we are going to discuss every problem on 3 variables. There again we will discuss how to write matrix of quadratic form. Next, after writing matrix of quadratic form, what is the most important application on quadratic form? Just now I said, reducing a quadratic form to canonical form. So canonical form, quadratic form to canonical form. So canonical form means simply what we can say, by writing given quadratic form as sum of squares. Sum of squares. Sum of squares means you should not have xy term, yz term, zx term after reducing quadratic form to canonical form. For example, if you want to reduce this one to canonical form means you should keep only square elements. You have to eliminate or ignore or delete or using some other process eliminate this xy term, yz term, zx term. Then you will have canonical form. So canonical form means getting sum of squares for given quadratic form. For this, we are going to use one technique, that is orthogonalization technique. Using orthogonalization technique, I am going to reduce quadratic form to canonical form by taking help of eigenvalues and eigenvector, which we discussed in the previous classes. Next, the most important thing for quadratic form is how to find nature of quadratic form. Nature of quadratic form. To find nature of quadratic form, nature I am discussing now. Nature. There are different natures for a given quadratic form that can be decided by evaluating simply eigenvalues. If you find eigenvalues, to find eigenvalues, what you need to do? First, you have to write matrix of quadratic form. After writing matrix of quadratic form, next you need to evaluate characteristic equation. Next, solve that characteristic equation to get eigenvalues. We will discuss in detail while discussing problem. After finding eigenvalues, if all eigenvalues are positive, all eigenvalues are positive, then we say that nature of quadratic form is positive definite. Positive definite. We say the given quadratic form nature is positive definite if all eigenvalues are positive. We say the given quadratic form nature as negative definite. Negative definite if all eigenvalues are negative. That means here you will have eigenvalues like 1, 2, 3. Here you may have eigenvalues like -2, -4, -6. Then we can say the nature of quadratic form is negative definite. Next, positive semi-definite. We can say the nature of given quadratic form is positive semi-definite if all eigenvalues are positive. Along with positive values, you should have at least 1 0. That means eigenvalue should be like this, lambda greater than or equal to 0. That means what I am saying, along with positive eigenvalues, you should have 1 0 like this. If you have eigenvalues like this, then we say the nature of quadratic form is positive semi-definite. Like that, negative semi-definite. Negative semi-definite means like positive semi-definite. Here the eigenvalue should be negative. Along with negative values, you should have at least 1 0. That means the eigenvalues are like this, -1, -2, 0. Then we say the nature of quadratic form is positive semi-definite. Like that, other nature, indefinite. Indefinite nature we will have for given quadratic form remaining all cases. Other than these 4 cases, if you get any other case, we say that the nature of quadratic form is indefinite. That means if you have eigenvalues like this, you are having negatives, positives, 0, then it does not comes under any of 4 which I discussed. Then we say that the nature of quadratic form is indefinite. Next, in the same quadratic form only, after reducing a quadratic form to canonical form, we need to decide the rank of quadratic form, index of quadratic form, signature of quadratic form. How to decide rank, index and signature? To decide rank of quadratic form, simply what we can say, the number of positive squares you are having in the canonical form. The number of positive squares, or you are getting sum of squares means what it means, finally you are getting a diagonal matrix, because square element coefficients we are going to write in diagonal only, like this. After this we will write canonical form, y1 square plus 2y2 square plus 3y3 square. After getting this, we are going to write like this. Before this step, you will have a diagonal matrix. Basing on that also one can decide rank. Rank means nothing, number of non-zero terms here. How many terms you are having non-zero terms? 3. That is rank. Next, index. Index means nothing more, number of positive terms. Number of positive terms in canonical form of quadratic form, or number of positive squares. So getting to this example, here how many positive terms you are having? Non-zero positive terms, 1, 2, 3. So index will be 3. Similarly, what is signature? Signature means nothing more, the number of positive terms over negative, or difference between positive and negative in the canonical form. Here the number of positive terms are 1, 2, 3. Do you have negative terms? No. Negative terms 0. Number of positive terms 3 minus number of negative terms 0. 3 minus 0, 3. 3 will be the signature. What happens generally in the question, first he will say reduce quadratic form to canonical form. Next he will ask and hence find rank, index, signature and nature. For that, this theory helps you to decide the rank of quadratic form, index of quadratic form, signature of quadratic form and nature of quadratic form. Do you clear now how to find nature, index, signature? Find the nature of quadratic form. This is important for short answer questions. We need to find nature for this quadratic form. To find nature of quadratic form, first we have to write matrix EM. Matrix of quadratic form you need to write first. Matrix of quadratic form. To write matrix of quadratic form, I said one technique for 2 variables just now. Now I am going to discuss for 3 variables. Here, how many variables you are having? 3, x, y, z. So for 3 variables, you need to prepare like this small matrix x, y, z, x, y, z. Now multiply. X into x, x square. X into y, x, y. X into z, x, z. Yx, y square, y, z. Next, zx, zy, z square. Now in that position, you need to keep the elements. As I said, in the principal diagonal, keep square element coefficients. So a equal to square element, x square coefficient here, y square coefficient here, z square coefficient here. Next, we need to write remaining elements. xy. Do you have xy in the quadratic form? No, you don't have xy in the quadratic form. Simply write 0. Next, xz. Do you have xz? No xz. So xz 0. Next, yx. Do you have yx? No yx. 0. Next, yz. Do you have yz? Yes. So if you have yz, what I said, simply make half all these coefficients you need to make half. So take half ma. YZ coefficient to 2 by 2, 1. Do you have ZX here ma? No, 0. Do you have ZY? Yes, ZY and YZ are same. So its coefficient you need to make half, 2 by 2, 1. So this is matrix of quadratic form. After writing matrix of quadratic form, to find the nature of quadratic form, first you need to find eigenvalues. To find eigenvalues, write characteristic equation. Characteristic equation of A. What is characteristic equation of A? Det A minus lambda equal to 0. That means simply subtract lambda from the diagonal elements only. 2 minus lambda 0, 1. 0, 2 minus lambda 1. 0, 1, 2 minus lambda equal to 0. I said one small technique to write this characteristic equation mark. So to write characteristic equation, one easy technique is, first is for every 3 by 3 matrix minus lambda cube term. Next lambda square you will have, that lambda square coefficient is sum of diagonal elements. Sum of diagonal. So simply add these three. 2 plus 2 plus 2. How much? 6 lambda square. Minus sum of cofactors of principal diagonal. Sum of cofactors of principal diagonal you will get like this one. For 2 corresponding column row is eliminated. 2 2s are 4, 4 minus 1, 3. Next to part 2, second 2. Second row, second column is eliminated. 2 2s are 4. 2 2s are 4, 0 minus 0, 0, 4. Next to part 2, last row, last column is eliminated. 2 2s are 4. So, what is my value? 4 plus 4, 8. 8 plus 3, 11. So, 11 lambda plus det A. Det A means nothing more, very easy here. Det A is 2 into 2 corresponding column row eliminated. That one we calculated. 4 minus 1, 3. 2 3s are 6. 6. So remaining 2 no need to find more. Plus minus plus. 0 into anything 0. 0 into anything 0. So 2 into its cofactor 3. 2 3s are 6. So this is characteristic equation of A. After finding characteristic equation of A, next to find out its roots more. Roots. I said in the previous class how to find roots using synthetic division. First write its coefficients. Minus 1, lambda square coefficient 6, lambda coefficient minus 11, constant 6. So to decide one is factor for this equation or not, first add all the coefficients. If you get 0, you can fearlessly write 1 here. So lambda equal to 1 will be the root. So add 6 plus 6, 12. Minus 11 minus 1 minus 12. 12 minus 12, 0. So that means lambda equal to 1 is 1 root. So to find remaining roots, I am using synthetic division like this. First write 0 here. Minus 1 plus 0 minus 1. Minus 1 into 1 minus 1. 6 minus 1, 5. 5 1 5. Minus 11 plus 5 minus 6. Minus 6 into 1 minus 6. So gives you 0. Here if you get 0, then lambda equal to 1 is factor. 1 is root. Then the factor will be like this. I am going to write lambda minus 1 minus lambda square plus 5 lambda minus 6 equal to 0. Because one coefficient is become 0. So from lambda square you need to write. Now lambda minus 1 0 means lambda minus 1 0. Lambda minus 1 0 means lambda value is 1. Next, write these are in factors. This equation in factors. That one you know very well. 6 factors. 2 3s are 6. 2 3s are 6. So that means this can be written like this. Lambda minus 2, lambda minus 3. So finally, what are the eigenvalues you are going to get? Lambda equal to 1, 2, 3. So all eigenvalues are positive here. All eigenvalues are positive. All eigenvalues are positive. If all eigenvalues are positive, just now I said nature of quadratic form is positive definite. positive definite. Nature of quadratic form is positive definite. This is the way to decide nature of quadratic form. Write characteristic equation, find out eigenvalues. Basing on the conditions what I said in nature, you can write the nature of quadratic form. Okay, ma? Clear? So now we are going to discuss the key concept in quadratic form. How to reduce a quadratic form to canonical form by orthogonalization technique, orthogonal transformation technique. As I said just now, reducing quadratic form to canonical form means writing given quadratic form as sum of squares. For that, these steps we are going to follow. First, write matrix of quadratic form. I said how to write matrix of quadratic form. Matrix of quadratic form. First write matrix of quadratic form, which is called A. After writing matrix of quadratic form A, next find eigenvalues and eigenvectors. For example, A is 3 by 3 matrix. Eigenvalues are lambda 1, lambda 2, lambda 3. Eigenvectors you will get like this. Eigenvectors x1, x2, x3 by assuming the matrix 3 by 3. Now write normalized matrix P. P matrix, we call that one as normalized matrix P. Normalized matrix P, which is like this: x1 by norm x1, x2 by norm x2, x3 by norm x3. So I said how to write x1 by norm x1. With one example I am explaining here. If x equal to ABC, then x1 by norm x1 will be written like this one: a by root of a square plus b square plus c square, b by root of a square plus b square plus c square, c by root of a square plus b square plus c square. Like this, you need to write x1 by norm x1, x2 by norm x2, x3 by norm x3. Why we are writing like this? To make P as orthogonal matrix. If you write like this, then P becomes orthogonal. If P is orthogonal, then what is our advantage mark? Instead of finding P inverse, if you find P transpose, that is enough. After finding P transpose, find P transpose. After finding P transpose, next calculate P transpose AP value 1. This P transpose AP will be a diagonal matrix D, in which you will have diagonal lambda 1, lambda 2, lambda 3. So in diagonal you will have lambda 1, lambda 2, lambda 3. What I mean to say is, you will have a matrix like this. This is I am saying D. After getting D matrix, find or write canonical form of given quadratic form. Write CF of given quadratic form. That CF is y power t dy. Generally we assume y like this. Generally y is, for every problem, y1, y2, y3. Y power t dy means, y power t means y transpose. Column matrix becomes row. Y power t means, that means like this you will get y1, y2, y3. D matrix I written lambda 1, 0, 0, lambda 2, 0, 0, 0, lambda 3. Again y matrix ma y1, y2, y3. If you multiply these three, you will get canonical form as sum of squares like this: lambda 1 y1 square plus lambda 2 y2 square plus lambda 3 y3 square. So this is the procedure we are going to use to reduce given quadratic form to canonical form by orthogonal transformation. By using this procedure, we are going to solve few problems now. Okay. So now we are going to reduce this quadratic form to canonical form by orthogonal reduction. Just now I said the procedure. Using that procedure, I am going to reduce given quadratic form to canonical form. For that, first write matrix of quadratic form. Matrix of quadratic form. You all know how to write matrix of quadratic form. I said just now. First keep square element coefficients in the diagonal. Square element coefficients 3, 5, 3. After keeping square element coefficients in the principal diagonal, I said this is the procedure. Again I am explaining the procedure to write matrix of quadratic form. 3 variables x, y, z, x, y, z. So what you will have x square, x, y, x, z, y, x, y square, y, z, z x, z, y, z square. So you need to make these all half, 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 half. Square element coefficients are over. Next, here you need to write xy coefficient half. Xy coefficient is minus 2 half minus 1. Next xz. Xz coefficient is 2. 2 by 2 is 1. Next yx. Yx coefficient again minus 2. Minus 2 by 2 minus 1. Next y square is there. Next yz. Yz coefficient minus 2, its half is minus 1. Zx. Zx coefficient again 2, its half is 1. Zy. Zy coefficient, zy, yz are same, its coefficient is minus 2. Minus 2 by 2 is minus 1. Now this is matrix of quadratic form. From this matrix we need to write characteristic equation. Characteristic equation of A, which is det A minus lambda equal to 0. So det 3 minus lambda minus 1, 1. Simply subtract lambda in the diagonal. Minus 1, 5 minus lambda minus 1, 1 minus 1, 3 minus lambda equal to 0. This one I said how to write characteristic equation in easy way by using one technique. That technique I am applying again. Minus lambda cube. So lambda square coefficient is sum of diagonal elements into lambda square. If you add all 3 plus 5 8, 8 plus 3 11. Like this, if you find sum of cofactors for every element, you will get 36 ma. Similarly det also 36. I said how to find det using calculator. How to find det, you know, I said for the previous problems, for every problem I explained how to find sum of cofactors of principal diagonal, how to find det. Like that I written 36 more. Next we need to find lambda values. For that we are taking help of synthetic division. Here you need to write coefficients minus 1, 11, minus 36, plus 36. Actually if you add all these coefficients, if you get 0 then one factor. If you add all 36 plus 11 should not be equal to minus 36 minus 1. So if you add all coefficients, you cannot get 0. Then 1 is not factor. Then try with 2. So that means write here 0. Minus 1 plus 0, minus 1. Minus 1 into 2, minus 2. 11 minus 2, 9. 9 2s are 18. Minus 36 plus 18, minus 18. Minus 18 into 2, minus 36. So then what you will get? Lambda minus 2 minus lambda square plus 9 lambda minus 18 equal to 0. You all know that 18 factors are 6 3s are 18 because 6 plus 3 is 9. 9 2s are also 18. 9 minus 2 you won't get 9. That's why 6 3s are you need to take here. Now the factors will be like this: lambda minus 2, lambda minus 6, lambda minus 3 equal to 0. Then what you will get? Lambda values 2, 3, 6. These are eigenvalues. Next, in the previous problems I said how to find det of a matrix using calculator, how to find a square, a cube, like that. But now I am going to give you one small technique to find lambda values using calculator. So here I am giving that operations now, especially Casio scientific calculator FX 991 ES or FX 991 ES plus calci. If you take that calci, in that you can easily solve this equation. By solving this equation you will get that values. For that follow these steps now. First on the calci, I am giving these operations to solve a third degree equation. A third degree equation like this. First on the calci. Next you will have one button, mode ma. Press mode button. Next press 5. 5 will be the equations option. In that third degree equation you need to solve. So press 4 ma, last option. If you press 4, calci, in the calci display it will ask A value, B value, C value, D value. These values you can enter coefficients ma. Lambda cube coefficient is A. What is lambda cube coefficient? -1. -1. Enter. Next press equal to. Next cursor will move to B value ma. There enter lambda square coefficient. Enter 11 and press equal to. Then cursor will be at C. Now enter -36 equal to. Next D value 36 equal to. After pressing equal to, press equal to 3 times ma, you will get this value. If you press equal to first time, you will get 2. If you press equal to second time, you will get 3. If you press equal to third time, you will get 6. Like this also, one can easily calculate eigenvalues using calculator without this synthetic division. Clear ma? Next we need to find eigenvectors ma. Just now we evaluated eigenvalues 2, 3, 6. For corresponding to lambda 1 equal to 2, lambda 2 equal to 3, lambda 3 equal to 6, we need to calculate eigenvectors. So first eigenvector corresponding to lambda 1 equal to 2. For this, you need to subtract 2 from the diagonal. 2 from the diagonal of matrix A. You know matrix A already. That one we written. So from the diagonal only you need to subtract 3 minus 2. Diagonal you will have these 3 only. So 3 minus 2, 1. Next, in the place of xy you will have this one half. In the place of xz you will have here 1. Next, here second row first column xy coefficient only -1. Here you will have 5. 5 minus 2, 3. Next, yz coefficient -2 only, -1. So next, here xz coefficient also 1. Next, zy coefficient -1. Here you will have 3 minus 2, 1. This one you will have ma. This is A matrix already you written. In the A matrix, from the principal diagonal, I am going to subtract 2 from the principal diagonal only. What is A matrix already you know. That matrix if you want you can keep there so that you can understand. In the A matrix, matrix of quadratic form, from the principal diagonal only, I am subtracting 2. After subtracting 2, x1 will be x1, x2, x3. Here you will get 0, 0, 0. I said one easiest technique to find eigenvectors. General way of finding eigenvectors is solving this homogeneous system by applying row operations only, but it will take a very lengthy process. That's why I am using one shortcut. I said that shortcut in this matrix, write from any two rows, second element to second element. What is second element here? -1, 1, 1, -1. Where you start, you have to end with that element only. Take second row from second element, 3, -1, -1, 3. Here x1, x2, x3. This is AD minus BC technique. AD minus BC technique. x1 by -1 into -1, 1. 1 minus 3, -2. x2 by 1 into -1, -1. In between you will have minus into minus plus, -1 plus 1, 0. x3 by 1 into 3, 3, -1. 3 minus 1, 2. Now cancel with 2 all elements. 2 1s are 2, -1. Here you will have 0. Cancel here also with 2, 2 1s are 2. So the first eigenvector you will get, x1 will be k into -1, 0, 1. The k is assumption. Actually we need to assume x3 as k, then you have to calculate. I am using one shortcut. That's why I written here k. Using that shortcut, you got minus 1, 0, 1. Next, coming to the second eigenvector. Second eigenvalue, you know ma, eigenvector corresponding to lambda 2 equal to 3. Eigenvalues are 2, 3, 6, 2 over next 3. For that, a minus lambda 2 into I into x2 equal to O. Here, you need to subtract 3 from the diagonal. Diagonal elements are 3, 5, 3. So subtract 3 from the diagonal. If you subtract 3 from the diagonal, 3 minus 3, 0. Remaining elements are same. Minus 1, 1. Here, minus 1, minus 1. Here, what element you may have? 5. 5 minus 3, 2. Here also, 1 minus 1 same. Here, which element you may have? Z square coefficient, 3. From 3, subtract 3. 3 minus 3, 0. x1, x2, x3 equal to 0, 0, 0. Now, as I said in the previous case, like that only, from second element to second element, from any two rows, you need to write the elements. Second element, minus 1, 1, 0, minus 1. Next, here also from second element, 2, minus 1, minus 1, 2. This will be x1, x2, x3. AD minus BC technique ma. AD minus BC technique. x1 by minus 1 into minus 1, 1. 1 minus 2, 1 are 2. 1 minus 2, minus 1. x2 by 1 into minus 1, minus 1. 0 into anything, 0. x3 by 0 into 2, 0. Minus into minus plus. Minus, you will have AD minus BC technique. 0 into 2, 0. Minus 1. All are minus 1s. When you have all are minus, you can cancel all minus. Then, what is second eigenvector? 1, 1, 1. Second eigenvector. Like that, we need to find third eigenvector. Third eigenvector corresponding to lambda 3 equal to 6. That means a minus lambda 3 into I into x3 equal to O. That means you need to subtract 6 from the diagonal. 6 from the diagonal. You need to subtract 6 from the diagonal. Diagonal elements, you know. Diagonal is 3, 5, 3. If you subtract 6 from the diagonal, 3 minus 6, minus 3. Next two elements will be same. Minus 1, 1. Minus 1, minus 1. Here you will have 5. 5 minus 6, minus 1. Last row, 1 minus 1. Last element will be 3. 3 minus 6, minus 3. So, as usual, from second element to second element, you need to write minus 1, 1, minus 3, minus 1. Here all minus 1s. 3 minus 1s. So, x1, x2, x3. x1 by minus 1 into minus 1 plus 1. In between you will have minus, minus into minus plus. Minus 1 into minus 1, 1 plus 1. 1 plus 1, 2. x2 by here 1 into minus 1, minus 1, minus 3. Minus 1, minus 3, minus 4. x3 by minus 3 into minus 1, 3, minus 1, 2. If you cancel with 2, x1 by 1, x2 by minus 2, x3 by 1. So, the final eigenvector is k into 1 minus 2, 1. These are the three eigenvectors. By using these three eigenvectors, we need to write matrix P. Next, we have to diagonalize this quadratic form. That we will discuss in writing matrix P. Next, we need to write P matrix. These are the three eigenvectors just now we evaluated. x1, x2, x3. By using these three x1, x2, x3, we need to write P. P equal to x1 by norm x1, x2 by norm x2, x3 by norm x3. Normalized P we need to write. I said how to write normalized P using the formula which I had given in the procedure. Simply Add these 3. By squaring, add the 3 elements. Minus 1 whole square 1. 0 square 0. 1 square 1. If you add, what you will get? 2. Minus 1 whole square 1. 1 square 1. 1 plus 1 2. So keep that 1 in the denominator like this. Minus 1 by root 2. 0. 1 by root 2. Next. Add these 3. 1 square plus 1 square plus 1 square. 1 plus 1 plus 1. 3. So that one you need to keep in the denominator like this. 1 by root 3. 1 by root 3. 1 by root 3. Here. 1 square is 1. 1 square is 1. 2 square is 4. 4 plus 2, 6. That 6 you need to keep in the denominator like this. Minus 2 by root 6. 1 by root 6. This will be the P. Next we need to find P transpose. P transpose means the transpose of a matrix is obtained by interchanging row as column. Make row as column. Here first row I am writing here as column. Minus 1 by root 2. 1 by root 3. 1 by root 6. Next, second row as second column, 0, 1 by root 3, minus 2 by root 6. Third row as third column, 1 by root 2, 1 by root 3, 1 by root 6. Next, you need to calculate P transpose A P. P transpose is this one. A matrix already we written, quadratic form, matrix of quadratic form, and P. If you multiply these 3 matrices, you will get a diagonal matrix. That diagonal matrix I said, in that diagonal matrix, simply keep eigenvalues. No need to multiply. If you want, you can write the 3 matrix, but no need to multiply. Answer we know well before solving the problem. Where we evaluated eigenvalues, there itself answer is decided. Answer is 2, 0, 0, 0, 3, 0, 0, 0, 6. This is D. For every problem, you will get like this only. So eigenvalues, if you get 1, 2, 3, answer is 1, 0, 0, 0, 2, 0, 0, 0, 3. If you get eigenvalues 1, 2, 4, 1, 0, 0, 0, 2, 0, 0, 0, 4. So this is one small technique to reduce the time. No need to multiply. If you multiply, time waste. Already problem is very lengthy. Directly you can keep eigenvalues in the principal diagonal. This is D. Next, what we need to find? Canonical form we need to find. Canonical form. Canonical form means you need to multiply these 3 y power t dy. I said what is y? For every problem, y is y1, y2, y3 y power t means you need to transpose. If you transpose column matrix, you will get row. y1, y2, y3. D matrix is here. 2, 0, 0, 0, 3, 0, 0, 0, 6. Here you will have y1, y2, y3. Just we have a formula for canonical form, that's why I am writing. But without writing this formula also, with this matrix you can write the canonical form. Canonical form means sum of squares, only square elements you will have. That means 2y1 square plus 3y2 square plus 6y3 square. Like that you can write the canonical form without mentioning these all. Directly from here you can write 2y1 square plus 3y2 square plus 6y3 square, because you know we keep square element coefficients in the principal diagonal. If you have non-zero elements in principal diagonal, that means they are square element coefficients. Canonical form means writing given quadratic form as sum of squares. What exactly we got now? I written given quadratic form as sum of squares. So this is canonical form of given quadratic form. This is the procedure to reduce a quadratic form to canonical form by orthogonal reduction. I said so many shortcuts, use these all shortcuts so that you can solve this problem in less time. Otherwise, it will take much time to solve the problem, maybe 30 minutes also. Take help of calculator and use these techniques and use this technique to write canonical form. Okay, are you clear how to reduce quadratic form to canonical form? Okay, bro. Next, we are going to reduce another quadratic form to canonical form. As we discussed in the previous problem, same procedure, similar manner. I am going to reduce this one to canonical form. For that, first write matrix of quadratic form. Matrix of quadratic form. A equal to, first keep square element coefficients in the principal diagonal. 1, 3, 3. Next, you are having only one non-square element, that is x2, x3. For this type of problems, we can use another technique without writing that matrix. We can directly write x2, x3 means in the position second row, third column and third row, second column, you need to write half of the coefficient. Second row, third column, second row, third element, half of this minus 2, minus 1. Third row, second element, half of this minus 2. Third row, second element also minus 1. We don't have any other elements other than square. That's why you can keep remaining places 0, 0, 0. So this is the matrix of quadratic form for the given quadratic form. Next, we need to write the characteristic equation. Characteristic equation of A, which is det A minus lambda I equal to 0. Det 1 minus lambda 0, 0, 0, 3 minus lambda minus 1, 0, minus 1, 3 minus lambda equal to 0. This one I said how to write characteristic equation. Shortcut. What is that shortcut? Minus lambda cube plus sum of diagonal elements. Add these 3. 1 plus 3 plus 3. 7 lambda square. Sum of cofactors you will get 14 1. Det A is 8. I said how to calculate sum of cofactors and det A using calci, and sum of cofactors also you can take one element, one cofactor, delete one corresponding column row, 3 3s are 9, minus 1, like that for 3 elements you need to do. Next, find out lambda values using synthetic division. For synthetic division, first write coefficients minus 1, 7, minus 14, 8. So here I said how to decide whether lambda equal to 1 is root for that equation or not. First add these all coefficients. 7 plus 8, 15, plus 15, minus 15, 0. So lambda equal to 1, definitely a root. For that, write here 0. Minus 1 plus 0, minus 1. Minus 1 into 1, minus 1. 7 minus 1, 6. 6 1 are 6. Minus 14 plus 6, minus 8. Minus 8. You will get 0. Now, the factors will be like this. Lambda minus 1. Minus lambda square plus 6 lambda minus 8. So 8 factors, 2 4s are 4 plus 2 6. That's why the factors are lambda minus 1, lambda minus 2, lambda minus 4 equal to 0. Therefore eigenvalues are 1 to 4. I said how to find eigenvalues using calculator in the previous problem also. If you want, you can use calci to get 1 to 4. Now we need to find eigenvectors for this 1 to 4. Eigenvector corresponding to lambda 1 equal to 1. For that, A minus lambda 1 into I into x1 equal to 1. Subtract 1 from the diagonal. Subtract 1 from the diagonal. What you will get? 1 minus 1, 0, 0, 0, 0. 3 minus 1, 2, minus 1. 0, minus 1, 3 minus 1, 2, x1, x2, x3 equal to 0, 0, 0. Now write from second element to second element as we discussed in the previous eigenvectors. Because first row is completely 0 row, if you take first row, there is a chance of getting 0 vector. I said eigenvector never be a 0 vector. That's why I am taking from second and third row. 2 minus 1, 0, 2, minus 1, 2, 0, minus 1. x1, x2, x3. x1 by 4 minus 1, 3. x2 by 0. x3 by 0 you will get. So if you cancel 3 1s are 3. So what is the eigenvector you are getting. First eigenvector k 1 0 0. Like this we need to find eigenvectors for lambda equal to 2, lambda equal to 4. Okay, so next we will discuss eigenvector for lambda equal to 2. Are you clear for lambda equal to 1 ma? So next, second eigenvector for second eigenvalue, lambda 2 equal to 4 ma, a minus lambda 2 into y into x2 equal to. So subtract 4 from the diagonal ma, 1 minus 4 minus 3 0 0, 3 minus 4 minus 1 minus 1 0 minus 1, 3 minus 4 minus 1. Here x1 x2 x3 0 0 0, 1 minus 4 minus 3, 3 minus 4 minus 1, 3 minus 4 minus 1. From second element to second element ma, 0 0 minus 3 0. Like that here, this one also from second element, minus 1 minus 1 0 minus 1. So now x1 by x1 x2 x3, x1 by zeros you will get 0, x2 by 0 minus 3 you will get, x3 by 3 minus 0. So finally if you cancel with 3, x1 by 0, x2 by minus 1, x3 by 1, 3 1 are 3. So second eigenvector you will get 0 minus 1 1. Second. So now eigenvector corresponding to lambda 3 equal to 4 ma, a minus lambda 3 into x3 equal to O. So simply subtract 4 from the diagonal ma, 1 minus 4 minus 3 0 0, 3 minus 4 minus 1 minus 1 0, 3 minus 4 minus 1, x1 x2 x3 equal to 0 0 0. Now as usual from second element to second element ma, 0 0 minus 3 0, minus 1 minus 1 0 minus 1, x1 x2 x3, x1 by you will get 0 only, x2 by 0 minus 3, x3 by minus into minus plus ma 3. So now cancel with 3 you will get third eigenvector, cancel with 3, 3 1 ja 3 1 ja. So k 0 minus 1 1. After cancelling with 3, now we need to write P matrix ma, P equal to x1 by norm x1, x2 by norm x2, x3 by norm x3. You know x1 already, 1 0 0 already I said. So for x1 you won't get any change, same one you will get 1 0 0. x2 is minus 1 square 1, 1 square 1, 2 you will get 0, minus 1 by root 2, 1 by root 2, x3 square and add, what you will get ma? 0, minus 1 by root 2, 1 by root 2. So now find out P transpose ma. P transpose means nothing, simply add row, make row as column, write row as column ma. P transpose equal to 1 0 0, 0 minus 1 by root 2 minus 1 by root 2, 0 1 by root 2 1 by root 2. P transpose. After finding P transpose, next you need to find P transpose AP. P transpose AP is a diagonal matrix in which eigenvalues are principal diagonal elements 1 0 0, 0 2 0, 0 0 4. 1 2 4 you need to keep in the principal diagonal, that will be D. Now canonical form you all know ma. Canonical form is y power t dy. So y power t dy means y is y1 y2 y3. You need to multiply diagonal elements with y1 square, y2 square, y3 square. So 1 into y1 square plus 2 into y2 square plus 4 into y3 square. After this finding canonical form, in this question you will have to evaluate rank, index, signature, nature. Rank is nothing more. Simply from D I can explain easily. Number of non-zero elements in the diagonal. How many? 1, 2, 4, 3. Index. Number of positive terms. How many? 1, 2, 4, 3. Signature. Number of positive terms minus number of negative. Number of positive is 3 minus number of negative terms. No, 0. 3 minus 0, 3. Nature. Nature, all eigenvalues are positive. So, positive definite. Positive definite nature you will have. Rank 3, index 3, signature 3. Nature is positive definite. This is the way finding rank, index, signature for given quadratic form after reducing to canonical form. Are you clear, ma? Any doubts you can ask, ma?